In this video, we present Azcom Technology Vehicle in-Cabin Monitoring, a comprehensive automotive-grade, all-embedded software solution, including live presence detection, seats occupancy localization and classification, and driver's vital signs monitoring. This video starts demonstrating live presence detection and then seat occupancy localization and classification. First and second row are covered, exploiting TI AWR6843 antenna and package radar sensor, positioned centrally above the armrest of the first row. In this first part of the video, we demonstrate live presence detection feature through a small set of representative cases. All scenarios are performed in engine off, which is the relevant condition for this application. Once the Start button is clicked, the interface starts working and the system detects the presence of the baby, positioned on the right front seat in rear-facing mode. An alarm will appear in the center of the user interface. Now the baby is moved back to the rear row on the child seat placed on the right side of the car. Also in this case, after a few seconds, our solution detects the presence of the baby and activates an alert in the graphical user interface. There's now a further change in the scene. The baby is replaced by a water bottle while the vehicle is shaken from the outside to simulate wind, storms, or vehicles passing by. In this condition, the water bottle could easily lead the software to wrongly identify the object as a human being. The LPD system is able to correctly handle this situation. The water bottle is discriminated from a baby, and the graphical user interface doesn't show any alarm. In the last scenario, the water bottle is removed in order to test the case of a baby that accidentally falls on the car floor. Even this critical situation can be successfully handled by Azcom software. Now, in this second part of the video, occupancy, localization and classification are presented through some selected use cases recorded during a driving session. The graphical user interface is slightly different from the one presented in the previous video. Once the Start button is clicked, the interface starts working, and by the time the embedded software localizes and classifies the living occupants, green icons are shown accordingly to the scenario. The first case presents two adults in the front row. They are correctly detected and the decision remains stable as long as they remain in the car. A water bottle is now positioned on the left rear seat. Azcom software correctly reports a completely empty rear row and maintains this decision stable in time. Now the scenario is changed. In addition to the driver and to the passenger on the right seat of the front row, one child is located on a CRS in the central rear seat front-facing. The child is covered with a blanket, as typically happens with a sleeping baby. Azcom OLC software reliably detects the baby, as can be seen from the graphical user interface. In this last scenario, the baby is positioned on the right front seat in rear-facing mode, a position that can improve the safety of small babies in case of accident, while the second adult is on the left rear seat. In this condition, a correct detection and classification of the child occupant is very useful for intelligent airbag management and the possible airbag deactivation. Driver's vital signs monitoring is another important feature of our in-cabin monitoring solution. Also in this case, the radar sensor we are currently using is part of the Texas Instruments AWR family and is placed centrally on the top of the central panel in order to perform a contactless monitoring of heartbeat and respiratory rate. The driver is seated in the car. The graphical user interface on the left of the screen is active and displays, in real time, the cardiac and respiratory waveforms with the related heart and respiratory rates. The real-time data coming from the radar sensor are benchmarked against the measurements provided by a pulse oximeter positioned on the driver finger used as external reference. This demonstration video illustrates the radar technology at work in a real-world scenario. The driver behaves naturally. She talks and moves ahead while driving on a road presenting curves, holes, and discontinuities on the asphalt. Our software solution works by isolating small body displacements due to breathing and heart beating from motion caused by driving activity, as well as vibrations coming from the engine of the car or any external disturbances. This is all for now. Thanks for your attention. If you need further information about Azcom radar-based in-cabin monitoring solution, please contact us through www.azcomtech.com.